Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. So I was doing IGCSE Chemistry 0620 past papers and I'm done till question number 4 part E. So I will continue from part E. Part E. Methanol is manufactured by reacting carbon monoxide with hydrogen. COG plus 2H2G, reversible sign CH3OHG. The rate of formation of methanol increases when a catalyst is used. 1. Choose from the list the element that is most likely to be used as a catalyst. Draw a circle around your chosen answer. You have calcium, carbon, copper, sodium, sulfur. So copper must be the right answer. If you look at the position of copper, copper is among transition metals. Here we have copper. Part 2 state the effect on the position of equilibrium when a catalyst is used. So catalyst, the function of catalyst is that increases the rate of reaction in both directions. Increases the rate of reaction. So it will increase the rate of reaction in both the direction. So the net effect will be 0. So you will write no effect. Part 3. State the effect that the catalyst has on the activation energy EA of a reaction. You know that it decreases or lowers the activation energy of a reaction. So you write decreases or lowers the activation EA. EA is the activation energy of a reaction. Let's move on to next question. Here's question number 5. Part A. Lead 2 bromide PbBr2 is an insoluble salt and is made by precipitation. Number 1. Name 2 aqueous solutions that produce a precipitate of lead 2 bromide when they are mixed. You have to take soluble salt of lead. And you know that all nitrates are soluble. So straight away you will take lead nitrate as one of the salt. Now you want bromide. So you can take bromide of first group elements like sodium bromide, sodium or potassium or even ammonium. All these bromides are soluble. You can take one of these. Part 2. Describe how to produce a pure sample of lead 2 bromide from the mixture of aqueous solutions in A2, A1. So you will definitely get a precipitate of lead 2 bromide because it's an insoluble salt. So it will be left as a residue. So what you will do, you will filter it. First of all, you have to filter. Filter, then you will wash the residue and dry. Wash the residue and dry. You can dry in air or on tissue paper. Part 2, write an ionic equation for the precipitation reaction which produces lead 2 bromide, includes state symbols. So if you are going to write the reaction equation, it will take time. So what you'll do, you are making insoluble salt, lead 2 bromide. The formula of lead 2 bromide, it's given PbBr2. So you know that the product is PbBr2, so you will straight away write PbBr2 solid. So what must be the reactant? we must have Pb2. Pb2 means Pb will carry plus 2 charges. You write Pb plus 2 aqueous plus 2Br minus. Bromine belongs to group 7, which means it must be having -1 as its oxidation number or valency. B. When iron 2 sulfate crystals are heated strongly, sulfur dioxide gas is given off. Describe a test for sulfur dioxide gas. Sulfur dioxide gas, you can test the sulfur dioxide gas by passing it through acidified potassium manganate 7. Acidified potassium manganate 7. And the color, it will turn colorless. Purple, it's purple in color, it will turn to colors, purple to colorless. The next part C, complete the equation for the thermal decomposition of hydrated cobalt to nitrate. You have 2 CONO3 whole twice, dot 4H2O gives blank CuO plus blank NO2 plus blank H2O. So in order to balance this CO on the right hand side, you will write 2 before COO. What about NO2? You have 2 multiplied by 2, 4 N here on the left hand side. So you'll write 4 before NO2. What about hydrogen? 4 multiplied by 2, 8. 8 multiplied by 2, 16. So it means you have to write 8 here. This will be the final balance equation. Part D, hydrated cobalt 2 sulfate COSO4.XH2 produces water when it is heated. This is the reaction. COSO4.XH2O S gives COSO4 S plus XH2O G. A student does an experiment to determine the value of X in COSO4.XH2O. Step number 1, the student weighs a sample of hydrated cobalt 2 sulfate. Step number 2, the student heats the sample of hydrated cobalt 2 sulfate. Step number 3, the student weighs the remaining solid after heating. Number 1, describe what else the student should do to ensure that all the water has been given off. No other substances are required. So what the student will do, the student will heat it again and weigh again until constant mass obtained. So you write heat again and weigh again until constant mass is obtained. Part 2, in an experiment, 1.405 gram of COSO4.XH2O is heated until all the water is given off. The mass of COSO4 that remains is 0.775 gram. MR of COSO4 and H2O is given. Determine the value of X using the following steps. So we'll follow these steps. Calculate the number of moles of COSO4 that remains. So in order to find the moles of COSO4, you have to divide the mass of COSO4 by the MR of COSO4. So what we will do, we will divide 0.775 by 165. And the answer must be 0.005 moles. Calculate the mass of H2O given off. In order to get the mass of H2O, what we will do, we will subtract 0.775 from 1.405. 1.405 minus 0.775. So the answer is 0.63 grams. Calculate the number of moles of H2O given off. Now, in order to find the moles of H2O, we need to divide the mass of H2O by the MR of H2O. 0.63 divided by 18. And we'll be getting 0.035 moles of water. Determine the value of X. So the number of moles of CuSO4, 0.005. 0.005 moles react with 0.035 moles of H2O. Therefore, 1 mole react with X mole of H2O. Do the cross. So it will become 0.035. Divided by 0.005. 7 will be the value of X here. Number 6. This question is about metals. A, figure 6.1 shows a blast furnace used to extract iron from its ore. Blast furnace. Number 1, coke and iron ore are added at the top of the blast furnace. Name one other substance that is added at the top of the blast furnace. It's calcium carbonate or limestone. Part 2. Name the substance that leaves the blast furnace at A. So, above A, you are getting slag. So, A must be the molten iron here. You'll be getting molten iron. So, I will write molten iron. Number 3. Slag is produced from an impurity in iron ore. Name the impurity in iron ore that is converted into slag. Just name the impurity which is present in iron ore which is converted into slag. And that impurity is silicon dioxide or silicon 4 oxide. Silicon 4 oxide. Number 4. Name 2 substances that react together to produce the high temperature in the blast furnace. Now name the 2 substances that are reacting together to produce a high temperature in the blast furnace. It must be carbon and oxygen. They will react to produce carbon dioxide, and due to this temperature, the blast furnace rises. Number 5. Name 2 waste gases that leave the blast furnace. Now we have hot air introduced here. So we know that in the air we have other gases also. So those gases will leave the blast furnace. So you can write any 2 of these gases. Any 2 from. You have nitrogen, argon. Argon is the most prominent, or so is the only inert gas that's present in the high percentage in the air. And carbon dioxide also leave the blast furnace. So I will write carbon dioxide. Part B, zinc is produced from zinc oxide in a furnace. In a furnace, zinc is produced from zinc oxide. The zinc is produced as a gas. It then forms molten zinc. Number one suggests why the zinc produced inside the furnace is a gas. So it must be the temperature. The temperature must be above the boiling point of zinc. Temperature above boiling point of zinc. Number two, state the name of the physical change that occurs when gaseous zinc is converted into molten zinc. So you are converting gaseous zinc into molten zinc, which means you are converting gas into liquid. Gas into liquid. So the process must be condensation. Part C. Zinc is used to coat iron to prevent rusting. Number one, name the process used to coat iron with zinc as a method of rust prevention. Typical process, we call it galvanizing. Galvanizing. Number two, when the zinc coating is crashed, iron underneath does not rust. Now, zinc coating is crashed, but the iron underneath it does not rust. Explain why the iron underneath the zinc does not rust. So definitely does not rust. Definitely, zinc lose electrons. Zinc lose electrons or oxidize. You can even write oxidizes or oxidizes in preference to iron. In preference to iron. You can write any other equivalent paraphrase also. The zinc oxide neutralizes both acids and bases. One, state the journal name given to oxide that neutralizes both acids and bases. We call it amphoteric. Number two, when zinc oxide neutralizes aqueous sodium hydroxide, sodium zincate is formed. The formula of the zincate ion is ZnO2 minus. Deduce the formula of sodium zincate. Now you need to predict the formula of sodium zincate. We have Na here, zincate ion ZnO2, it's carrying 2 minus charge. If you look at the position of sodium, it's in group 1, which means it must be carrying +1 charge. +1 will be the valency of sodium here. So ignore the charges. Swap these numbers. You will get Na2 Zn Na2 Zn O2. So you write Na2 Zn O2. Name the zinc compound that forms when zinc oxide neutralizes dilute sulfuric acid. Now, zinc oxide, when it reacts with, so you have zinc ion coming here, and you have sulfate coming from sulfuric acid. So straight away you write zinc sulfate. Going to next question. Question number 7. Many organic compounds contain carbon and hydrogen only. A1 organic compound A has the following composition by mass. C 82.76%, H 17.24%. Calculate the empirical formula of compound A. You have C and hydrogen here. C is 82.76%, hydrogen is 17.2%. We need nucleon number of AR of carbon and hydrogen. Carbon here is carbon, 12 is for carbon, 1 is for hydrogen. So for carbon is 12, for hydrogen is 1. For carbon, it's 2.76. We get 6.896. For hydrogen, we will get 17.24. 6.896 is smallest combining ratio or mole ratio here. So 6.896 will be divided by 6.896. We'll get 1 here. For hydrogen, 17.24 divided by 6.896. We'll get 2.5. Now you can't round off 2.5. You have to multiply to get the answer in whole number. So if we'll multiply both the numbers by 2, what you will get? Here you will get 2. In case of hydrogen, you will get 5. So final empirical formula must be C2H5. Moving to next part. Part 2, compound B has the empirical formula CH2 and a relative molecular mass of 70. Determine the molecular formula of compound B. We need to find the value of N, which is molecular mass divided by empirical mass. Molecular mass is given, empirical mass must be of this. So MR of CH2 is empirical mass. Empirical formula mass. So carbon is 12 plus 2, you will get 14. So in order to get the N, you will divide 70 by 14. 5 will be the answer. So we'll multiply 5 by CH2. So the molecular formula must be C5H10. This will be the final molecular formula. Part B. Figure 7.1 shows a section of polymer Q. Figure 7.1. Draw the displayed formula of the monomer that forms polymer Q. We need to draw the displayed formula. First of all, find the repeat unit. So repeat unit must be this. These two will be repeated. So the monomer must be having this displayed formula. Name the monomer used to form polymer Q. So what will be the name for this one? We have 1, 2, 3, 4. It's butene. Butene. Moving to next part, which is part C. Propene C3H6 can be produced by heating C11H12. The products of the reaction are propene, hydrogen, and one other product in a 1:1:1 mole ratio. Complete the symbol equation for this reaction. So 11 minus 3. So you must be having C8 as a C8. The compound must be of C8. What about the number of hydrogen in this compound? So 6 plus 2 is 8. 24 minus 8. C8H16. So it must be the other product because it's also of 1 in ratio. These all are 1:1 in ratio. D. Carboxylic acids and esters contain carbon, hydrogen, and oxygen only. An ester X and a carboxylic acid Y both contain 3 carbon atoms. X and Y have the same molecular formula. Number 1, state the name given to compounds with the same molecular formula but different structure formula. We call it structural isomers. Structural isomers. Part 2. Esters are made by the reaction between carboxylic acids and alcohols. Ester X is methyl ethanoate. Name the carboxylic acid and the alcohol used to make methyl ethanoate. So for the carboxylic acid, you need to look at the alkanoid ion, which is ethanoid here. So it must be coming from ethanoic acid. So for carboxylic acid, you will write ethanoic acid. What about the alcohol? Alcohol must be the one providing alkyl group. Here must be having methyl group. So it must be coming from methanol. So I will write methanol for alcohol. Part 3. Draw the displayed formula of carboxylic acid. Y. Name the carboxylic acid. So you have to draw the displayed formula of the carboxylic acid. Y. So carboxylic acid, it's of 3 carbon atoms. So N must be 2 for this carboxylic acid. N must be 2. Remember, for carboxylic acid, the number of total number of carbon atom must include carbon of COOH. Recall the general formula of carboxylic acid, which is CnH2n plus 1 COOH. So N is 2, we'll have C2, H, 3 2s are 6, 6 plus 1, 7, H7 COOH. It means it must be propanoic acid. Propanoic acid. So I need to draw the displayed formula of propanoic acid. So we have 1, 2, 3. It's COOH. And now I'm going to saturate the other carbon atoms, placing the hydrogen atoms. Sorry, it must be C2H5 COOH. It's not C2H7. It's C2H5 COOH. You see, they have 1, 2, 1, 2, 3, 4, 5 hydrogen atoms, COOH. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.